So my dear friends, in this video I would like to explain the indexing or the dividing head. So indexing head is an attachment used in milling machine for uh, dividing the workpiece or the surface of the workpiece into equal divisions. For example, suppose you want to cut gear on a cylindrical blank. There we need to cut the teeth on a cylindrical surface one after the other one. So based on the number of teeth required, we have to divide the total length or the circumference into that much required divisions for having that much number of teeth. For example, if we have 10 number of teeth, we want to cut the 10 number of teeth on a cylindrical surface. After each cut of teeth, we had to turn the workpiece 360 divided by 10, that is 36 degree. So that means we are dividing the total circumference into 10 equal divisions. So that is actually known as indexing. So indexing is very important when you want to machine. For example, if you want to cut a gear or if you want to make a hexagonal or octagonal surface from a cylindrical blank. So this is one of the method by using indexing head. It's widely used in milling machine. Used to divide the circumference of workpiece into equally spaced divisions. For example, when we want to mill gear teeth or squares or hexagons or octagons, etc. So this is the indexing head. The important parts of the indexing heads is the headstock. This is actually the main component, that is the headstock. All the mechanism of indexing is incorporated in this head. And this is the spindle where we are holding the workpiece. This is the spindle. And this is the indexing crank which we want to rotate, turn for getting this indexed. And this is the middle support. If we are using long slender workpiece, we have to support in the middle, so we can use this center rest. And this is the back support by using footstock. So this is the total mechanism for this index. So now you see this how this mechanism works. So this is very simple. The only thing is we have to remember that we want to rotate or turn the workpiece in equal intervals, and this axis of the workpiece is perpendicular to the indexing crank. So we need to use a worm and worm wheel. So this is the front side of the machine or indexing head, where we have a crank. This is a crank with a crank wheel, index wheel, and we can see a plate where we have a number of poles, pole circles, and the sector arm. And this crank is connected to the worm shaft, and at the end of the worm shaft there is a worm which is engaged with the worm wheel, and worm wheel axis is actually the axis of rotation of the workpiece. So this is connected to the in indexing head spindle, and that spindle is actually holding the workpiece. So how it works? So this is very simple. When you rotate the crank, so that will turn the worm shaft, because this is firmly fixed on the worm shaft. So worm shaft will be rotated, So when we rotate the worm shaft, worm also will rotate. So the worm wheel is engaged with the worm, so worm wheel also rotates. And for one full rotation of the worm shaft turns the worm wheel one teeth or one tooth. When we rotate the crank 360 degree, that will rotate the worm shaft one full rotation, and that will rotate the worm wheel 1/4, as there are 40 teeth here, only one teeth will be moving. So it will rotate only one tooth, because that is 1/40. Suppose if you want to rotate the entire, that means full rotation of the worm wheel, we have to turn the crank 40 times. So if you turn this crank 40 times, that will turn the worm wheel one full rotation. Okay. So this already we have explained the different parts of the index net. Now we will see what are the different types of indexing. So mainly there are four types of indexing methods. First one is direct indexing, then second simple indexing, third one is angular indexing, and the fourth one is differential indexing or compound indexing. So what is direct indexing? It is very simple. That means you are just directly rotating the work spindle or turning the work spindle into equal number of uh, divisions. That means after cutting one operations, after one machining operations, you are turning the spindle of the workpiece to a certain angle. Simplest form of index. It is performed by disengaging a worm shaft. That means here you are not using the worm and worm shaft, so it should be disengaged from worm wheel by means of eccentric device in dividing head, and they use for quick indexing of workpiece when cutting floats, hexagons, squares, etc. So this is used for a small number of divisions, for example 4, 8, etc. There we have a full division, that means 360 by 4 or 360 by 8, uh, like that. For example, 360 by 4 means it is 90. So just to turn the work or work spindle 90 degree. There you can use the circle plate. You can use the circle plate, and it is having number of holes, hole circles. For select a hole circle, for example 24 hole circles. So you divide that 24 into equal number of divisions which is required, and turn the that circle plate into that much angle. So yeah, that means you are directly turning the workpiece for the getting the equal number of divisions. That is known as direct indexing. That is simple and normally used for the minimum number of divisions, and all there should not be any fraction. That means based on the available whole circles, you can divide that whole circle into equal number of divisions. For example, direct indexing plate usually contains three sets of whole circles or slots, 24, 30, and 36. The number of divisions possible to index limited to numbers that are factors of 24, 30, and 36. This is very simple. For example, if you are using 24 whole circle and you need, for example, you need 6 divisions. For example, we want to cut a hexagon on a cylindrical surface, so it has to index 6 times because we need 6 sides. So if you are using a 24 whole circles, 24 by 6, that is 4. That means in the 24 whole circles, after each machining operations, after each cutting, you have to turn the uh, that circle plate four holes, after each cutting operation. So you'll be getting 6 faces. So these are some of the examples, milling a square with the direct indexing. So square only 4 sides are required. That is no need to again explain. Then comes second indexing is simple indexing. Simple indexing is widely used because here we can have any number of teeth. Any number of teeth we can cut. Lot of combinations are available. And work position by means of crank, index place, and sector arms. So here we use crank, index plate, and sector arms. And worm and worm wheel also, that mechanism also used. Worm attached to crank must be engaged with the worm wheel. And as you know, there are 40 teeth on worm wheel. One complete turn on index crank causes spindle and work to rotate 1/40th of a turn. That means if you turn one complete turn on an index crank, that will turn the workpiece 1/40, 1/40, because there are only 40 teeth on the worm wheel. So calculating the indexing or number of turns of crank for most divisions, simply divide 40 by number of divisions to be cut. So that is the actual method. Suppose we need 36 number of teeth, just 40 by n. N is equal to 36. So that is the equation used in the simple indexing. The indexing required to cut 8 fruit means 40 by 8. So 40 by 5, 40 by 8 is actually 5. So 5 full turns of index crank. So if we have to turn index crank 5 times after each machining operations. After each cut you turn the index crank 5 times, full 5 times. There is no fraction. The indexing required to cut 7 fruit means 40 by 7, that is equal to 5 by 7. So 5 full rotation and 5 by 7 fraction is also there. That means the 5/7 turn involves use of index plate and sector arms. Understand? The 5/7 turns, that is fraction needs, we have to use the index plate and sector arms. So that's there we are the application of the sector arm and the circle place or index plate is required. So what is index plate? Index plate is circular plate provided with a series of equally spaced holes into which index crank pin engages. So I told you there is an index crank and one end of the index crank is having a pin or plunger type pin that will go into the circle of the index plate or a whole of the circle or whole circle of the index plate. And the sector arm, it is fit on front of the plate and may be set to any portion of the complete turn. So actually if you are using an 18 circle index plate on the index plate, 18 hole circle, and you only need 5 by 18, that means only you need 5 holes. You want to turn only 5 holes in that 18 hole circle. So you can set that sector to 5 holes only, so that after each operations, after each cutting operations, you can turn that index crank to that much only. So that is only for easiness of turning that required angle fraction by using this sector arm. So sector arm we can set by tightening the nut. For example, if you want to finish indexing for 7 fruits, that means 7 sides. So first of all, we had to choose the whole circle in the index plate. So for example, here we can have plate 1, plate 2, plate 3. and in the plate 2 you can see 21 whole circles are available. 21. So as we have 7 divisions, we need 7 divisions. So actually it is 40 by 7. 40 by 7. So that is actually the 40 by n. N is 7. 40 by n is 7. So the fraction, choose any whole circles that is divisible by denominator by 7. So 5 by 7, that is equal to 15 by 21. So the 7 the multiple of 7 is 21. So we have to select this 21 whole circle. So it's in that 21 whole circles, we need only 5. So 5 to be multiplied by 3. So you will be getting 15 by 21. So you can use only 15 whole circles. So 5 full turn plus 15 holes on 20 or 21 whole circles. 5 full turns. That is 5 by 7. That is actually 40 by 7. 40 by 7 is equal to 5 5 by 7. 5 means 5 full rotation. That we know how to do it. Then there is fraction 5 by 7, that we have to see whether there is available whole circle. So here available whole circle is 21. So to get 21 we have to multiply both the numerator and denominator by 3. So you'll be getting 15 by 21. So that what it means, it means that in 21 whole circle you have to rotate, you have to turn the crank only 15 holes. It's a fraction. So this is how we are doing this symbol indexing to turn the workpiece into equal divisions. That's all. Next we will see compound indexing. What is compound indexing? Sometimes the required number of divisions or teeth will not be getting by using simple indexing. Then we have to use compound indexing. The word compound indexing is indicative of compound movement of indexing crank and then plate along with the crank. So here a compound movement is there. So first we are rotating the crank alone, and the next rotation is crank together with the index plate. So that is not done in the simple indexing. In the simple indexing, we are only rotating the crank. We are only rotating the crank. There, the indexing plate is stationary. But in the compound indexing, for getting the required number of teeth, first of all, we are rotating the crank. Then, after rotating the crank only, we have to turn a certain degree both crank and the index plate. So that is why it is known as compound index. So in this case, indexing plate is normally held stationary by a lock pin. So that is in simple indexing, we are normally doing like this. That means the indexing plate is stationary and it is locked by using a locking pin. First we rotate the index crank. In this case, compound indexing, first of all we have to rotate the indexing crank through a required number of holes in a selected hole circle. Then crank is fixed through pin. It is followed by another movement, that is important, by disengaging the rear lock pin. That means we are disengaging the locking pin of the indexing plate, and you can freely rotate the indexing plate together with the indexing crank. So that is why it is known as compound indexing. Now we'll see with an example. For example, let us we want to make 69 divisions, which is not possible by simple index. 69 divisions on a workpiece. So first of all, we have to see the factor of the divisions to make, that is 69. So 69 we can write 3 into 23. So the total number of teeth or divisions required are 69. So that is equal to 3 into 23. Now we will select two whole circles. As a random you can select. So trial and error. So let it be 27 and 33. Two whole circles. These two whole circles are available on a single this one indexing plate. Now we have some calculation like this. Subtract smaller number of holes from the larger. That means 33 minus 27. That is equal to 6. 6 can be written as 2 into 3. That means everything we are writing with the this fractions. Factor the number of turns of the crank required for one revolution of the spindle 14. Also factorize the selector process. So we have to factorize all these values. So 69 can be factorized into 23 by 3. 6 equal to 2 by 3. And in the denominator, we have to this factorize 40, that is the number of teeth on the boom wheel. 27 is the whole circle we have selected, that is also factorized 3 by 3 by 3. 33 is another whole circle we have selected, that is 3 into 11. Now see whether we can simplify this one. For example, you can see whether this will. So finally we have to get only these factors. But here this is 23 and here 11 is there. 23 and 11. If all the factors above the line are cancelled by those which are below the line, then the selector about circles can be used. In this case, there is need to select another whole circles. Let us select 23 and 33. 23 and 33. Here we have selected only 20, 33 and 27. 33 and 27. But we cannot solve this one, so we have reselected as 23 and 33 two whole circles. Now we'll see again. Factorize this 69 23 by 3 10. That is the difference. The difference between these two numbers, 33 minus 23 is 10. 10 can be factorized into 2 into 5 divided by, this is the number of divisions or the number of teeth on the worm wheel. That is we can factorize like this. Then 22 is the whole circle we have newly selected, and 33 20 not 22, this is 23. So 23 can be written as 23 into 1. 33 is 11 into 3. Now we can see here all these we can cancel except this rounded or circled numbers. All we can cancel from numerator and denominator. Finally, we will get only these values in the denominator, 2 into 2 into 11. So encircled numbers below the lines are left out after cancelling the common factors. Now by using the following formula, we can represent this 40 by 69, that is actually the basic equation in the indexing, that is 40 by n. N is the number of teeth required, that is 69. So 40 by 69 can be rewritten as n1 by n1 plus or minus n2 by n2. What is n1? This n1 is actually the selected whole circle. So in this case, 23 is the selected n1. n2 is the another number of whole circles we have selected, that is 33. Now we have to find out what is small n1 and small n2. So multiply all the remaining factors below the line. So here we have all numbers left out, all cancelled, and the left out numbers are in the denominator 2 into 2 into 11. So finally what it will be? It will be 44. So 44 is the N1. So 40 by 69 is equal to 44 by 23 minus 44 by 30. So we will get we will neglect the positive side. So we can select only negative. Positive will not be getting this one. So only either positive or negative. In this case it is negative minus. So this can be written 44 by 23 can be rewritten as 121 by 23 minus 111 by 33. What it indicates? It indicates that if you are using a 23 whole circle plate, you have to rotate one full rotation plus 21 whole circles in that 23 whole circle. That means not complete fraction. And here also, if you are using 33 whole circle plate, you have to turn one full rotation plus 11 whole circles. And what indicates minus? So here this is direct indexing or this is simple indexing. Here you are only rotating the crank, and here in this case you are both rotating the crank as well as the indexing plate. Okay, that means for indexing 69 divisions, the indexing crank should be moved by 21 whole circles in the forward direction, and then crank along with the plate are moved by 11 holes in the 33 whole circles in the reverse manner because it is negative minus. So the second time when we rotate the crank with the indexing plate, we have to turn in the opposite direction. So this will be repeated after each cut. So this is the index. So this is known as compound indexing. So both this compound indexing and simple indexing are used for getting required number of divisions. So that's it.